Hello everyone, I'm very glad to work with you together in this semester to study Introduction of Renewable Energy course. Today, I would like to provide you an overview on the course. The course overview will share with you the information of course introduction, the course objective, the textbook used in this course, and the course content, the time schedule, and the evaluation of the course. Introduction of Renewable Energy course is a fundamental course that provides basic knowledge of electrical engineering, power system, and renewable energies. It is a compulsory course with 2 credits and 32 teaching hours. The course will be held every Monday from 2 p.m. to 4 p.m. The objective of this course include 3 aspects. The first aspect is knowledge. In terms of knowledge, this course will help you understand renewable energies, learn industry practice, and build a foundation for future courses. The second aspect of the course objective is to improve language. This course will help you to enhance listening, reading, speaking, and writing skills of English. You will learn technical terms by reading the textbooks. You can improve listening skills through watching videos. And you can enhance the writing skills by doing the homework. You will also have opportunity to practice your English speaking skills by giving presentations. The third aspect of the course objective is the self-learning skills. This course will also help you develop self-learning skills. You will learn how to investigate, ask the right questions, develop your own opinion, and solve problems by yourselves. The textbook used in this course is Renewable and Efficient Electric Power Systems, published by Wiley and written by Gilbert Masters. Why do we choose this book? Because this book is written primarily as a textbook for new courses on renewable and efficient electrical systems. The book will not only introduce electric energy. The book will not only introduce renewable energy technologies, but also provide fundamental knowledge of electricity and the power system. The book also covers historical, regulatory, and the utility industry aspect. The outline of this course. The book includes 9 chapters. Due to limited teaching hours, we only will study 5 chapters. We're going to study Chapter 1, Basic Electric and Magnetic Circuits. Chapter 2, Fundamentals of Electric Power. Chapter 3, The Electric Power Industry. Chapter 6, Wind Power Systems. And Chapter 9, Photovoltaic Systems. Chapter 1, Basic Electric Magnetic Circuits. Introduce the basic concepts of electricity and magnetism needed to understand electric circuits. Chapter 2 is a practical orientation to electric power as a power factor, transmission line, 3-phase power, and power supplies. Chapter 3, the electric power industry, provides an overview of the development of today's electric power industry, including regulatory and historical evolution of the industry, as well as the technical side of the power generation. Chapter 6, Wind Power Systems. This chapter develops techniques for evaluating the power available in the wind and how efficiently it can be captured and converted to electricity in modern wind turbines. Chapter 9 is Photovoltaic Systems. Chapter 9 is a very heavy design-oriented approach to PV systems, with an emphasis on grid-connected, rooftop designs, off-grid standalone systems, and PV water pumping systems. Now, let's look at the schedule. The schedule is listed in the teaching calendar document. You can download the teaching calendar document from remote teaching platform under University MIS system. We're going to start the chapter 1, basic electric and magnetic circuits from week 1. Week 1 will cover chapter 1.1 to 1.5, including introduction to electric circuits, definitions of key electrical quantities, idealized voltage and current sources, resistance and capacitance. You need to read the textbook before the class and write down the technical terms. This will help you to understand the content during the class. Not all of the content will be taught in the classroom because of limited teaching hours. For example, section 1.1 is a self-learning section, which means that you need to learn the Introduction to Electric Circuits section by yourself. The requirement on each section is listed in the course outline document. The course outline document can also be downloaded from remote teaching system under University MIS system. The homework is also listed in the teaching calendar document. For example, in week 1, the homework is to complete the questions of chapter 1-1 to 1-6. Those questions are listed at the end of the chapter 1 in the textbook. The week 2 will teach chapter 1.6 to 1.8. 1.6 is magnetic circuit. 1.7 introduces inductance. 1.8 talks about transformers. Week 3 will start chapter 2, Fundamental of Electric Power. Section 2.1 is effective value of voltage and current. Section 2.2 is idealized component subjected to sinusoidal voltages. 2.3 is power sector. 2.4 is the power triangle and the power factor correction. We will continue chapter 2 in week 4. 2.5 3-wire single-phase residential wiring, 2.6 three-phase systems, and 2.7 power supplies will be taught in week 4. Chapter 3, the electric power industry, will start in week 5. The 3.1, the early pioneers, is also a self-learning session. We're going to teach 3.2, the electric utility industry today, 3.3, polyphase synchronous generators, 3.4, paneled efficiency for heat engines in the classroom. Week 6 will teach sections 3.5 to 3.8, including steam cycle power plants, combustion gas turbines, combined cycle power plants, gas turbines, and combined cycle cogeneration. Week 7 will teach 3.9 to 3.12, covering baseload, intermittent, and peaking power plants, transmission and distribution, the regulatory side of electricity power, and the emergency of competitive market. 3.11 and 3.12, the regulatory side of electric power and the emergency of competitive market will also be self-learning session. There will be a midterm examination in week 8. Starting from week 9, we're going to teach Chapter 6, Wind Power Systems. 6.1, Historical Development of Wind Power is also a self-learning session. 6.2, Types of wind turbines and power in the wind will be taught in the classroom. Chapter 10 teaches section 6.4 to section 6.6, including impact of tower head, the maximum rotor efficiency, and the wind turbine generator. Week 11 presents Chapter 6.7 to 6.9. 6.7 is speed control for maximum power. 6.8 is average power in the wind. 6.9 is simple estimate of wind turbine energy. Week 12 will introduce from Chapter 6.10 to 6.12. 6.10 is specific wind turbine performance calculations. 6.11 is wind turbine economics, and 6.12 is environmental impact of wind turbines. Section 6.12 and 6.11, the wind turbine economics and the environmental impact of wind turbines, are self-learning sections. Starting from week 13, we're going to teach the Chapter 9, Photovoltaic Systems. The 9.1 is introduction of the major photovoltaic system types. 9.2 is the current voltage curve for loads. Week 14 will teach 9.3 to 9.4. 9.3 is a grid connected systems. 9.4 is a grid connected PV system economics. Week 15 covers 9.5 and 9.6. 9.5 is the standalone PV systems. 9.6 is PV powered water pumping. The PV powered water pumping is also a self-learning session. And the last week, week 16, is the final examination. Regarding evaluation, attendance and quiz will count for 10%. Homework accounts for 20%. Midterm examination accounts for 20%. And the final examination is 50%. So hopefully by now you will have a good understanding of the course outline, and wish you good luck in this semester.